Everybody, good morning for the people in the US, good evening for the people in Europe. Welcome to the session on machine learning, cognitive science. Today we are about to talk about building systems to retain valuable clients, therefore avoid churn with Microsoft Azure Machine Learning. This is Professor Giuseppe Mascarella, and the goal of this analysis is to contact those high-risk clients, users, students with actions. It can be discounts, promos, interventions to prevent them from leaving the service, the institution. So we're looking at positive actions into the science. I would like to share a little bit of background about myself so you understand where I come from and why I choose certain content from a certain point of view, because what you see today generally is seen from a pure data, and I try to mix this from a business point of view. So I'm an adjunct professor at Florida Atlantic University. I run my private consulting company, Value Amplify. We offer 1 hour free consulting to anybody who wants to follow up on this. I worked at Microsoft for over 16 years as the worldwide manager for the strategy consulting group, and I even found the time to write a very interesting book that has sold thousands of units. It is called Rapid Economic Justification. That means how you link information technology progress into the outcome, the benefit, and the value that is generated. So you're going to see a lot of relationship between business and data and technology during this section. You can contact me by email, by Twitter, and on LinkedIn. And LinkedIn, I did a post in the polls about this session, so you can continue to have a conversation about this session on LinkedIn and extend this to more business people, in addition to the amazing past user community. The agenda for today has 3 elements. An introduction to machine learning, an analysis of what is that we're talking about, what is churn, what is attrition, and then how we do the predicting. So machine learning is a revolution. We used to write application, build system, spending thousands of hours as an analyst building those diagrams and documenting the logics, and we realized that over time the logic was becoming like spaghetti, too cumbersome. Sometimes instead of trying to reverse engineer the reality, we just probably want to measure the reality and let the computer extract a logic from the data. So that is what is happening, and machine learning is the tool. So machine learning is a scientific discipline that explores the construction and study of algorithms that can learn from data. Such algorithms operate by building a model based on input and using to make prediction and decision rather than following only explicit programmed instructions, what I was calling the work from the analyst. And this comes from Wikipedia, so it's quite independent definition, but I completely support this point of view. You may find a lot of other definitions, but this is the one I like the most and I want to share with you. Most of you coming from the SQL Pass community might be familiar with Microsoft analytic services. Well, and I get this question very often and say, well, what's the difference? Can we do machine learning in SaaS, or do we really need to jump off? Well, there is a lot. Most of the algorithms are also present on the cloud, and Azure Machine Learning are also in Microsoft SQL SaaS. But from a pure productivity point of view, from a pure capacity to elaborate and use additional tool without much of a configuration installation, you can see that on average a project done on Azure Microsoft Machine Learning is way faster. I mean, in the first part, in plan and prepare, generally we go from 8 weeks to 2 weeks. Then in build and validate from 4 to 2. So There is some advantage, but it's not exclusively the only way to go about it. The output of using machine learning, it's not a number. Most of the people think that it's just a data issue. No, it's just a new generation of applications. A generation of application that gives you an information at the service that you want. It discloses in certain curves the probability, the accuracy of that. It means that it's always aware of the fact that things are never perfect, and represents information and action in a context, like you can see here in this light green and dark green, in a context of what is that has more relevance to what you're studying. Think about the churning. In this case, think about darker means a high probability of the customer changing provider. Leaving a lighter green means less probability, and no green means that the customer is not at risk, and so on. So this is the new generation application we're talking about with machine learning. That generally is used as a web service behind a graphical user interface like the one you see. So I hope that I gave a little bit of understanding of the technology we're going to deal with today. And now let's go and study the churn and what is generally called attrition. For example, I teach, and in the academic world, the churning is called attrition, for example, in many other industries as well. So you need to be familiar that there's two ways to call the same thing. In modeling a churn, we have those steps. So if we go from left to right, the first step is the data on the user, the data on the activities, and the definition of churn, because that is the key aspects for your business. What is churn? Then you move to data tagging. That is not data cleaning. It's something way more sophisticated. We're going to do that. And at the same time, when you start looking at data, exploring data, generally you want to do visualization to see trends, to see what happens if we look by department. But today I'm going to spend a little bit of time on that because it's generally something that people either do visualization or do machine learning. In reality, you need to do both to obtain the best result. And sometimes when visualization is not good enough, you might want to ask actually the intervention of machine learning to do clustering association rules to help you understand what to visualize. So this is like already a loop that helps you understand a lot about the business, about how you can create value. Once you've completed this data exploration phase, you go to the second part. It's called experiment 2, that is feature engineering. Completed that, you move to experiment 3, that is training and evaluation. This is the part where you deal with the algorithm. And the last is about scoring, understanding the precision, the risk you're taking by executing on the recommendation of the algorithm. Let's go and analyze the first part, the data. So the data, generally you need to have users, activities. So let's look, users. Generally you have the customer profile, age, education, occupation, marital status, gender, and then you have activities, what you do. The intersection of those two generally gives what is called the customer satisfaction. In the case of a phone company, try to understand if you're moving from T-Mobile to AT&T or something like that, generally look like is the drop rate, the call drop rate, something that is a major factor, or failure rate, or number of complaints whenever called. You can have the best network, but your call center might be rude. And so the combination of those two give you customer satisfaction information, but again, you need to think about how you calculate, how do you have an index that is the failure rate. It's what do you multiply, what do you divide. So that is part of that goes from data tagging to feature engineering. Then you have data that you do not own, but very powerful for you. It does have a social network, and I teach that. And the most powerful tool right now is a sentiment analysis. If you use sentiment analysis that is generally based on machine learning, by the way, you definitely know if people are talking about you, but if people are talking positively, negatively, frustrated, extremely mad, and that really help you collect data that otherwise you will not know. And generally also you can see trends in the external world that impact your internal world. Even if you do everything right, there might be something else that impact churn and you need to worry about it. And that is, as you can see, usage trends that can be detected in many ways, but social media could be something very powerful. So when you combine all this, at the end of the day, you can predict if a customer will churn. Actually, people think the company like TNT knows if you are going to churn before you decide. In the sense, like even banks, in the sense that when you start receiving certain promotions, certain offers, when they tell you you can upgrade your phone now, even if you have not reached the 2-year limit of the contract, it's because the algorithm of machine learning is telling the telecom operator that there is high chance that you are about to call somebody, and before you call somebody, probably it's better that they lock you down for the next 2 years, or more than lock you down, that is a negative concept, that you show some love to the customer, for which the customer forgives you for whatever has happened and remain a valuable customer for the next 2 years. So let's give a little bit more precise definition about churn. So if we have user information, activity information, we need to define churn. Churn is the condition in which the success index has not passed the threshold in a certain amount of time. So churners are users, clients whose index of success is less than the churn threshold during the last n days seen in the activity information data. The most popular applications are telco subscribers. We all have a cell phone and we know how it goes. I teach, we try to analyze students that are about to leave or drop. We've done a lot of study on students at risk. We've learned a wealth about preventing what is a huge social cost on that. Banking and trading, you have two ways. In banking, are you moving your business to another bank? Or in trading, are you still doing those premium transactions that generates money? And if you're no longer doing them, is because you lost interest or you're doing with another institution? How do I understand if I'm doing something wrong or if I have some technical problem? And that is the typical application in banking. Software users, think about an application that understand that you're not doing something, and that means you're probably about to switch on another application, another web service, or probably it's time to show certain other menu because the menu you're showing are not what the user wants. You spend so much time trying to find other menus, therefore you need to rethink your graphical user interface. And that is actually one of the secrets of the most powerful software application. The application also readjusts to the user experience when they see that they are about to abandon. Video games are king into that. They know that if the mission is too difficult, you will give up and abandon the game. Well, predicting what is the threshold that will make the user abandon the mission or abandon the game and switch to your competitor game, it's critical to that. The next that we're doing an experiment and very interesting results is for restaurants. Understanding when somebody that generally comes regularly is no longer coming, and what can I do in terms of offers? Is it the glass of Prosecco, or is it a discount, or is it a special event? Try to understand what keeps your client loyal in your restaurant chain. It's exactly what we do with machine learning to prevent churn, and cost of acquisition of a customer is high. So why do you want to lose the one you have? So any business probably should first try to keep happy the current clients before spending the huge amount to get new clients all the time, right? So I hope by now it is clear what is the science of churn and attrition, and we can move on looking at how it looks like a result of an experiment on churn. So think about having a chart there. On the X you have the age on your loyalty network, and on the Y-axis you have the revenue, and you chart every user with a light green if there's no probability of churn, a darker green if there is high risk. You look at the data and you might think like, well, you know, there's we're all over the map. But if you look a little bit around the 600 hours of continuous user, you see a pattern there. And data visualization sometimes, or even that, can be very powerful because they can tell you that if you think there is no reason why internally this is happening, it might be that your competition is doing a promotion to target the people that pay more than $2,000 after 500 hours, and you're losing those premium customers. And of course, the first to leave are the ones that spend a lot, but then given the offer, even the people that are spending less and have no much of a reason to move, once they see the trends that friends talk about, you might see like that promotion becoming more effective even with a larger amount of user that even generate less of a premium amount of revenue. So as you can see, data can give us a lot of information about what is happening in the business and how we can serve our customer better. So now let's okay, sorry, for some reason. Okay, now let's go and look at visually okay. There was a slide here that for some reason I missed. I'm sorry, but okay. Let's talk about data tagging now, and as the first part of the process. Data tagging means you analyze the data you have, and generally you have a table where there are records, and the experiment I'm about to show you has about 5,000 customers of a fictitious telecom company. And in terms of columns and fields, you have the length of the customer account, the length of time, the number of minutes into the call in terms of days, whether night, whether in the evening, or in the international. And this is how you're going to see the data. This is the user data schema. There's a user ID, but this is a unique customer number, age, address, gender. Now, think about address. You know, this is all over the map. You know, you have like 8555 Collins Avenue, or Collins Road, or Collins Place. Machine learning cannot digest that kind of data. But at the same time, you want to know if this is happening in a certain part of the city or in the countryside, for example. So how do you handle this? So those are the technique of data tagging, where you decide to cluster them and create classes. So ages, you might want to do things like, let's take the baby boomers, or let's take the millennials. In address, you might take the zip codes, or whatever class you want to define. You just call them with a letter H, F, B, and then you give a meaning to that, and you run data experiments. So as you can see here, we have the first place where business and data cross. You define the category, not just dividing every 5 years there's a new category of users. You need to understand that users behave in the marketing world according to categories that generally are well defined in the industry, as baby boomer or millennials. In address, there is zip codes that allows me to go in Google and do advertising by zip code. So you need to think about actionable classifications so that once you have results, you can do things about that. Now, in data tagging, the other part is the activities. So sometimes you have things like a transaction ID that is a proprietary number, but it's a unique number. It's probably considered like a primary key. Then you have the timestamp. Then you have the ID of the item being purchased, the special service, the extension of the data plan. So you gotta define which data are required. And at this point, you don't know if they're gonna make a difference into the what moves the customer to churn or not to churn. So at this time, you are just doing exploration and preparation of the data. If you're doing preparation and exploration, okay, you are here. You are at the time where doing visualization is very important, because how do you know if required, this X is yes or no? You know because you go into that and you do this visualization. So in this chart here, we have the average historical score of the index of success, and on the y-axis, you have the recent score. Now, when we see that a certain user or a group of users falls behind this line, means that this person is still doing what has been doing forever. But if we see people crossing the line above, that means those people are up to something, or those categories are up to something, or those people using that type of service are up to something, and therefore you are crossing the famous threshold that define certain probability of risk, and therefore you need to put this into the investigation. So data visualization gives a preliminary analysis of what is that something that definitely you don't want to disregard at this stage. Another very powerful tool is box plotting. And in this case, for example, you might want to look at a category of clients by time and see if in a certain year you have had a difference. And for example, you see that in 2009, compared to the large population, you have a lot of outlier on top of the bottom. So this means that you didn't perform consistently. There was something that was not done in a proper way all the time. There were a lot of factors that were not planned. While you look at 2015, it seems that you've reduced the reaction of your clients by a large amount. Therefore, it means you have the business under control, and therefore means that when you do an action, you can get more benefits. If you are acting in a situation where the results have a large variety, you need to worry because probably the outcome are not going to be so predictable. And talking about how effective is going to be your option and regarding certain actions, you need to think about the power of standard deviation. And if you chart the standard deviation over time, you might end up discovering that there are things that have a low standard deviation. It means wherever you do, there's not going to be much change, and there are things that change. And in a broader spectrum, in the large picture, think about if you have a category of users that are disengaged, don't care, no matter how much promotion you do, they are not going to engage. Those have low standard deviation. They're going to stay on the lower part. So if I'm about to spend time to build an algorithm for promotion and actions, probably I need to prioritize that I want to target the people that have a high standard deviation, because those people are very sensitive to my actions. So I'm learning here that probably, let's assume for a moment, the millennials are not really reacting to printed coupons, and therefore if I'm in target right now, which target is, I might want to look at categories of users that have high standard deviation, and therefore means they really change when I do actions. At this point, let's move to features engineering. So feature engineer, after the data tagging was done, is the answer to the two typical questions on what are the possible variables that can intervene on the client at risk, and what do you need? Probability, for example, per each student, per each group, and generally leads to a binary classification, means it's a yes or no. So let's look at the chart that is really well built. So you start with the user info, no? the graphics about the user, and then on the right side you have activity info. Well, the activities at the high level, there are two. There are features related to text, what people write, the comment from your call center, the posting on social media, and things like that. On the other side, there are features related to numeric data. No matter what, if this is the month, the text, or a pure number already, you need to bring them to numbers that can be processed by machine learning. So generally, you take averages, and out of median, average, or other index, it could be standard deviation or ratios, you finally have all the data to prepare the complete list to feed the algorithm to make the prediction. Now, let's do some example. The example that I will show later on use some Python libraries, and for example, if you want to calculate the difference between two dates in terms of number of days, you don't need to rewrite the code. There is a library called calculate data diff. Well, first of all, Microsoft Machine Learning support R and Python, and in this experiment we're just using Python, but you could have used library that in R, and there are plenty and similar. And for example, you might want to calculate the standard deviation, no? And you say calculate a standard deviation X used to calculate numerical data feature function to calculate the standard deviation per user for different numerical fields. So those are the routine we're going to run when we move from data tagging to feature engineering. Means what are the 10 numbers the algorithm need to process to really give a meaningful indication to the business about things that will make a difference. This is, for example, what you are going to have. So you're going to have indexes, for example, total value per unique transactions. And that could be the result of 2 or 3 libraries. And at the end, you're going to get scored level. It's a churner or churner, but it's not about if you're a churner or not, because we're talking about human behavior. So when I was saying that the telecom company know that you're going to consider calling somebody else to switch, we're not saying about absolute truth. We know that there's a high probability that your behavior will be that. It's no longer engineering and math. This is about humans. And that numbers is what is very important. Now let's go to the other part of the modeling, that is running the training. There are many algorithms and 2-class classification, mid-class, regression, and there are different tools for different things. Now, if you want to, if you have a screw, sometimes you need a Phillips screwdriver or a conventional flat screwdriver. And sometimes you can use the flat for something that is across, should be the Phillips. So that's why here we have the first choice, and might work also with. For example, will my customer leave me for a competitor? That is the churn. the two-class classification is the first choice, and because it's a binary decision, either it will churn or not. The other conversation is that what is the probability is a second level conversation. Would they use a regression, that is an algorithm that will tell you the estimate of a certain value, like what would be sales in 6 months? Well, it could, but it's not definitely the best screwdriver for this kind of screws that we want to put in. And so are other algorithms. So this is just the first introduction to algorithm and business process. We're going to go deeper. This is the Microsoft Azure Machine Learning cheat sheet. So this is all the algorithms that are provided already into the system and how we navigate in choosing it. So if you have from the start point, something that, like, remember when I say visualization and you feel like those charts do not create anything that is meaningful, means there's no clear patterns evidence, or there are too many data sets that you can't really get anything visualization, then you use a technique called clustering, where there is an algorithm called k-means that will cluster data showing that across the last 5 years, all the people that are female, baby boomer and so on, typically buy plans in this way and don't pay monthly, pay like once a year. So those are the kind of things we're talking about. And what generally we create is a clustering of segments. And that's one way. This is called unsupervised learning because you let the machine group people just by the essence of data. On the other side, you have a supervised learning where you say, I tell you already, this is a problem that has an output that is yes or no, true or false. There's a binary. At that point, if it is a binary, you go here into what is called two-class classification. But even within that, you have several approaches. You have the two-class support vector, two-class average perceptron, two-class logistic regression, two-class Bayesian point machine, then two-class decision forest. And the decision forest is on the right compared to those other techniques, because this is a very different approach. We saw this in the demo, and so you can get to the same conclusion by looking at visually what are the possibility of the output and what is the probability, and you keep doing this kind of branching versus just pure math where there's no visualization and it's just pure algorithm. There are other algorithms, but I don't want to go beyond the scope of this conversation. I just want to let you know that there is plenty of them, and you just have a nice cheat sheet that can allow you to restrict what could be useful for what you need to do. And in our case, since we say that this is a binary outcome, churn or no churn, yes or no, you're gonna let's say the opportunity to try several algorithms, and you at the end of the day will make a decision based on the performance. You know, you will pick among the 20 the one that you think makes sense, but at the end of the day, the one that has the best outcome. So if in the experiment I'm about to show, if you use a logistic regression, you're going to have an accuracy of 92, and if you do both decision, 91. So that at the end of the day, you're going to pick that, but we're going to choose two just to see the differences. And sometimes actually you want to combine two because certain algorithms are good to do prediction in certain condition and others in others. So that's part of cognitive science finesse. One thing you learn in doing this exercise is that what are the variables that contribute to the decision. Now, in the universities, is it a bad professor that makes students run away? In a restaurant, is it a bad waitress or is a bad food experience? In the telco, is drop calls ratio or number of complaints? So in doing the prediction, the algorithm will give you some information that probably are more valuable than churn or no churn. That are the information about what can you do. You know, if we know that the customer is going to churn when he's doing a lot of transactions that comes with an index of 7.7, this means that when we have a frequent caller like business callers, probably your competition has a better offer. Go and put some of the smartest kids in your company and look into this scenario. And then the negative correlation is very interesting. It means that when a phone call, in the case of telecom company, has a high value of the transaction, means international calls, you have people that don't leave. What that means? That means that probably you are undercharging for international call, and there's a room there to look for profitability, while you're overcharging other things that make you lose customers. As you can see, your business really depends on your capacity to see the data other than guessing, or actually there is a famous label that MIT created, the opinion of the highest paid employee. So data tells the truth. In evaluation of the performance, that is the last step of our process, you need to, first of all, you need to consider the concept of confusion matrix. And in the PowerPoint that you're going to see, there is an hyperlink to a tutorial about that. But for the people that need a refresh, I assume that everybody knows it because this is the basics of cognitive science. Let's give a little refresh. What you have is that for the total prediction of machine learning, you can predict positive, means churn, and the customer really churn. That is a true positive prediction. But think about that, if you predicted that it's going to churn, but it didn't churn, this is a false positive, or what is called generally false alarm. Now, if you're about to make a big investment, knowing the false positive is probably very important, because you don't want to take prediction where the algorithm tells you that we have a lot of false positive. Remember the conversation where different algorithms are good for different things? Well, that's the kind of situation. Think about with medicine. If you're about to make a decision about certain treatments, no, you can't afford false alarm, false positive. No, you need to use the algorithm that may not be as performant, but it's more proper for avoiding this condition. On the other part, you have the predicted condition negative. It's not going to churn. It's a loyal client, and instead churn. Well, that is generally what is called the dogs. So while in the jargon of the industry, everything is called a cat except the predicting that will not churn in reality churn, and that is called the dog. So very soon, very often you're going to hear people talking about cats and dogs. In computer science, that's the meaning. I gotta tell you, the first time I heard somebody in advertising talk about that, I was like, why are we talking cats and dogs? But so now, don't run into the same situation I did. Now, those concepts are generally used in indexes that are very important in the industry, and one of them is called the accuracy, the ACC. So the accuracy is the number of the true positive predicted by the algorithm plus the number of the true negative divided by the total population. While if you do this number of the true positive divided by the population of the true negative, you have different indexes. But for simplicity and clarity in explanation, let's keep this to the very 2 or 3 elements that you guys can follow me. So Here you see the chord of true positive, and you know where to map. True positive is a condition, is the person really churn, and you predicted churn, and with this algorithm you had 582 out of 4,600 into the database. False negative 533. Those are the kind of things that if this was a medicine type of approach, it's unacceptable, right? But think about a scenario where this is acceptable. The accuracy, the ACC, is 0.698, but generally it's not really the best. Now, here, what you see is the threshold. You remember that churn, in the definition, it's when the index of success is lower than the planned threshold. Because for certain companies, you might decide that this is important, that you want to put very low threshold, or you want to really wait until the situation reaches such a volume for which you need to worry about it. That's a business decision. So this cursor here allows you to dynamic change the threshold. Now, those is a numerical analysis of what was produced. And as I mentioned before, this is what people think about machine learning. Machine learning produces numbers. Of course, I showed you earlier on that those numbers can be mapped into the new generation applications with those clear green, darker green, for which it's no longer for nerds. It's for business people as well. But at this stage, let's play a little bit around that, and let's look at this graphical representation. So this is a graphical representation of a false positive rate, okay? False positive, false alarm, and on one axis compare the true positive rate, means no false alarm. The people really were predicted and did it. Now think about if a data is on the diagonal, means that the probability was half-half, and no matter what you do, there was no reason to use machine learning or anything, because it's unpredictable. So being on the line is a bad place because it means there's nothing you can do. Being under is a bad thing because it means that you made the wrong decisions. The good thing is when you are on the upper left side of this square, that means that you had true positive, and you predicted a positive, and you had a true positive, and the more this curve is going towards these elements, in which means that very little false positive, a very high positive. So you think about a curve that does like this. I don't know, I'm sure you can see my mouse. That means it's a great algorithm. Now, in this case, we have two algorithms, the blue and the red, and you can see it's pretty good. Now, how do you measure if this is enough or more on the upper left side? There is a ratio that is called the area under the curve, and you're going to hear very often the AUC. In this area, the higher is the number, the more is the accuracy. 0.74, honestly, it's a starting point. In most of the cases, the customer expects over 80%. So I've had customers that say, we will not proceed unless it's 95%. Well, that's the business. And with that, I would like now to switch to a real environment where you see the IT side of it. And this is the data tagging. So you have data that you load with the reader. Oh, by the way, the database you have, the data set I was talking about, the 4,600 users from a fictitious health company, you find them here into the saved data sheet, into the samples, and as you can see, you have plenty of here and what you do is you just drag and drop them, okay? Now, the reader loads the data. You can use another box out of machine learning that is a tool to remove duplicate, cleaning missing data. This is big. So it's assuming that you're talking about the age of a user, and you don't have an age. Well, the machine learning doesn't like the fact there is no data. Machine learning will need either is a null or is something else. So you can decide that I'm going to replace this with a 0. Well, then it really screws every distribution, because it means you have newborn. So you can't put no data as a 0, as a null. You need to put something else. So you might want to put an average, but then you are probably making a mistake to push the algorithm to decide for a group of people that is not the most representative. So you might want to put the median that is part of that. So the decision on how to clean missing data is important. There is an entire part of it. Then you join the data between two groups of data set. But the most interesting part is this one. I want to spend some time on this. We say that churn highly depends on the amount of time where you plan to do something, in the sense like user that didn't come back to the restaurant in the last 6 weeks are the target for this promotional campaign, advertising campaign, and so on. Well, you might say that for you it's important that people didn't come in the last 2 weeks because you expect people to come often, because you are a lunch place in a business building, and if people didn't come for more than 2 weeks, it's already gone. You don't need to wait for 3 or 4 months. It will be like a night restaurant. So that is very important decision you need to make. So here you have a box that is entered determinedly. So here you go and enter the data. Of course, here in machine learning you have this view, but you can also create a form to input that. So you mix data that are loaded from a database with data that you input every time you want to run a simulation. You execute Python script, and the Python script that we're talking about are the ones that do cleansing, do calculation of certain indexes, and things like that. Then you go to this part. I just want to make sure we map into okay. So data tagging is what you're seeing right now. Then feature engineering means the selection of what variables matter, and that is the result of data tagging, might also be decision through visualization. Now we're going to go to step 3, that is training and evaluation. Okay, so step 3, training evaluation. You read the data that are the output of the feature engineering, the 10 data points that you care. You need to declare these data points as, let me do a visualization. It's probably the best way to show that. Here you are. So you need to define which data is a category, like age, D, like baby boomers, F, millennials, address, zip code. So you need to make sure all the data are clearly classified as continuous or categories. And this is the metadata editor. How do I select the data? The types. You can say that this is a label, and you take this one and you move here, and this is what is selected. For our experiments, for simplicity, we have selected age, address, gender, and user type. At this point, you prepare the data, and once you prepare the data, look at this here. You can exclude, include certain columns, and in this case, at the last moment, you take away the user ID, because for a cognitive science experiment, the unique idea of the customer, it's not really an information that tells you if he's more likely to move or not, unless your user ID was built with a code in which the first letter means the zip code, the second letter means that, but in the general where the user ID was built as the next available number, you need to exclude because it will not help the algorithm. At this point, you move to the important step of splitting the data. You split the data because you want to almost cheat on the machine learning, the artificial intelligence. You take, let's say, 70% of the data, and you give to the algorithm and say, do your job, and you hide 30% of the data because you want to compare if the prediction of machine learning will have predicted right what was the reality before going in production and spending money. So here I divide split rows, 0, 7, means 70% is what I'm going to send on the left part to the two algorithm, the two class and the two class logistic regression and two class decision tree. Of course, I can go here and change it as much as I want, and I can go and split the row by using a recommender, regular expression, or you just split. You decide it's 70-30, and you don't want the machine to do that. Anyways, so you give this the set that is the 70% for the algorithm into a system that is called the sweep parameters, on which the two class relation. So to understand this, we need to look at how the two class logistic regression works. You have options to make the algorithm predict things that have more false truths, more cats and dogs, pretty much. And very often you don't know exactly what is the implication of increasing the L2 regularization. This is really PhD level of computer science. So fortunately, Microsoft includes this functionality called sweep parameters. Means that the computer will try all the possible combination and come back to you saying that this combination here gives you the most, the highest accuracy. At this point, the algorithm working together sweep parameter will create the prediction system, and the score will evaluate if you are aiming a very high area under the curve. Very often you do this with two of them. It means that you are on the left you have the two class logistic regression, on the right you have the two class boosted decision, and then you compare the scoring of the two. You don't do this by hand. You do this with an evaluate to finally decide what to do. So now let's go a little bit deeper into what happens once the algorithm has run its magics and has pretty much evaluated the mathematical function. It gives you that those are the parameters here in a pure mathematical. But if you go in a boosted decision tree approach, look at the difference. You have different variables, and the interesting thing is that when you go into the sweep parameters, the different variables will be mapped no longer as a mathematical number, but it will map as a decision in terms of if the average time delta is less than 0.97, if this is a non-churner, then look at this. If you have a unique transaction ID, means that those remember the discussion about very high value transaction that typically could be an international call. Well, less than 35% is a non-churner. More is a churner. Well, that it's a quite interesting indication that you have a 70% of situation to analyze. So as you can see, decision trees have a different approach than pure mathematical progressing in making decisions. So different approach generally provide different performance. So let's look at the performance of the logistic regression. Let's visualize. I would say when I say you right-click on this node to visualize it, all right, and you see here the result says that for age E, D, and F, address H for this type of category. So this is like a category of identified unique segment to do run a marketing campaign, a promotion, a different treatment. Look at this. You're going to have at the very end, you have this category is a non-churner with 59% probability. Now, the others are quite low. You take the one that are the biggest category and you do some action around that. So for example, the first category here, which if you look at that, you can say that the category E address this zip code, and doesn't matter if it is a female or male, with this quantity of data coming from, and total value of the business of that will be a non-churner. Therefore, probably you don't need to do much about that. And the interesting part is the immediate visualization here. So this is the distribution, means you have a lot in this middle, in this category, and always less and less of a high probability. So this model is giving a lot of people the could churn, no churn, and you need to analyze it.
All right, Professor. It is 2 o'clock. I just want to be sensitive on the time here for everyone that's attending.
Well, actually, I'm done, so we made it. The thing is probably for questions, I will probably take one or two, and then the rest we demand on the online communities.
Sure, definitely. I just want to thank everyone for attending, and I want to thank you, Professor, for the great content that you presented once again to our group and our community. I just want to remind everyone that when you do sign off the session today, you will be asked a quick survey. If you could just fill that out, that would be great feedback for us as well as the presenter. And let's see, we do have a few questions here. One was, is there any design for threshold for the churn when you're designing this model?
Yes, when I say design, it's the methodology and tool to design that. There are different methodologies that generally are driven by the business decision making. And as I showed in this chart here, you need to just give an opportunity to the business to play around and change it. So it needs to be almost like a key performance indicator, very relevant to the top management that you want to monitor and you want to make decisions based on at the very high level.
Sure. And we did have a comment here. They thanked you for using the Python in this example. And I believe you already mentioned it, but this is possible to do the exact same thing using the R modules as well?
Yes, absolutely, yes.
Okay. Do you know, is in the Azure samples, is there a sample that people could go to reference for the churn?
Yes, if you go to the gallery of Azure Machine Learning, there are about 4 examples. This is pretty much a modification on an example that was there. So you look at the retail channel, you will find this experiment, but there are others that are very interesting. So yes, the gallery is a very good place to find several churn examples.
Perfect, great. Thank you so much. We'll follow up with everyone. We'll send the remaining questions to the professor to take a look at and give you feedback on. I want to thank everyone for attending. I want to thank you once again, Professor, for the great content. Do you have any last parting words for our audience?
we're preparing a new one, so stay tuned.
All right, sounds good. Thank you so much. Have a great day, everyone. Appreciate it.